Hello and welcome back to the Out of Spec podcast. I am here with Mike Doucleff, CEO of Alpitronic America. How are you doing, Mike?
Doing great, Isaiah. Great to see you again.
Awesome. Nice to see you again as well. Now, you guys are working on and maybe slowly rolling out your new HYC 1000 chargers and charging cabinet. Can you give us some of an idea of what that is and what Alpitronic is looking to expand?
Yeah, sure. Up until now, what Alpitronic has really been known for is our all-in-one DC fast charger. And that means that, the power from the grid is coming in the bottom of the charger, the power conversion happens inside the charger, and then the DC power is distributed through the cable. So this today, let's say our flagship product is called the HYC 400, which is a 400 kilowatt standalone or all-in-one DC fast charger. Now, with the HYC 1000, we're going to a distributed architecture. So instead of power conversion and power dispensers in the same unit, we're splitting them. So that means the power conversion AC/DC will be in the cabinet, and all of the dispensing of electrons will happen at the various dispensers. And the reason for that is really there's multiple reasons. Let's say um, I think the first point of view is we're starting to see higher and higher power needs from our customers, as well as more and more ports. So having a split system gives you the flexibility, one, to have more ports in one system at a better cost, but it's also giving you the ability to kind of future proof. So maybe today you don't need 1 megawatt on your system, but in the future you may. It's a way to have a no regret investment. So the first point is we're going from not only just a standalone all-in-one architecture like the HYC 400, but we're going to standalone and, okay, it's not or, so we're not replacing the HYC 400, it's and an HYC 1000. Now, in addition, in parallel to going from a standalone to a standalone plus distributed, we're adding as well the MCS connector. So that means this distributed architecture can host either passenger vehicles via passenger dispenser, so your normal CCS or NACS if you're in the US, but also the MCS dispenser for trucks.
Yeah, so for those who are not familiar, MCS, the megawatt charging standard, is what we would see in a lot of our larger EVs. Think semi trucks, some school buses implement those as well. What applications do you see the HYC 1000 being used versus where a HYC 400 wouldn't?
Yeah, it's going to be various applications. So there will be applications in the traditional CPO space where, depending on space, do you have enough room to have the standalone cabinet or a space at a premium? Also for more and more bays. So in the CPO space, when you need more and more bays, the distributed architecture becomes much more cost efficient. But then there will also be applications where you have a mix. So I want to have not only, let's say in the US, a CCS1 and an NACS connector for a passenger vehicle, but also I need space for an MCS connector for a commercial vehicle. So I think it's really a flexible, product line, and there's not one specific use case that it can be used for. It can be used for both passenger vehicles and commercial vehicles.
I'm thinking like parking lots, right? So, in essence, where there are a lot of electric vehicles in a large parking space, or there's higher demand, um, I guess that's where I guess you could see some of the HYC 1000 coming in place where the HYC 400 may not. Does that make sense?
Yeah, I mean, again, today in the 400, you're solving one use case, which is really about, having that full available power, per dispenser. Now, in the future, as you go, if you have 8 stalls, if those 8 stalls, for example, maybe you're not, having a full utilization of those all the time, and maybe you don't need necessarily, 400 kilowatts simultaneously across 4 or 8 ports, it becomes much more cost efficient, right? Because you're doing power sharing. So all of this 1 megawatt is shared across up to 8 ports per power unit. So it gives you a much more cost efficient way to spread the love, right, of the 1 megawatt across various ports.
Awesome. And that guess kind of speaks to the granularity of this station. Can you describe the dynamic load management that the HYC1000 has, the 62.5 kilowatt granularity? Can you describe
Yeah.
that?
Yeah, and that may seem like a very specific number, but I want to walk it back a bit and give you the history on the granularity. So, when we launched our first product line ever, it was the HYC 300, and that was based on four power stacks of 75 kilowatts each. Then in 2003, we migrated to silicon carbide power modules. And by doing that, we actually were able to increase our power density. So that's, delivering more power in the same volume power stack. So essentially the same physical footprint power stack, we increased the power density by 33%. So we went from a power stack that could deliver 75 kilowatts to a power stack that can deliver 100 kilowatts. Now that 100 kilowatts in the current version of the HYC 400, for example, today is split across two power modules. So there's two 50 kilowatt power modules per stack. For stacks, that means for the HYC 400, we can have granularity of 50 kilowatts or per power module. Now we've iterated again on the silicon carbide, and we've done another 25% increase in power density. So that means that what we're calling the six stack Gen 2, or the next generation of six stack, has even higher power density. So 125 kilowatts per six stack. Now, those six stacks, if you divide that by two, you can see that the power module is at 62.5. So, hence, in the future, for what we call the HYC 1000, that will have 8 six stacks, each at 125 kilowatts. So 8 times 125 gives you 1 megawatt. And the granularity, divide that by 2. The power units inside, or the power modules inside each of those six stacks, are 62.5. So that's why the granularity is at 62.5 on the HYC 1000.
Okay, that makes a little more sense. And I guess with the silicon carbide, this would also help with the increase in efficiency, as you said, with the increase of power density. You quote a efficiency rating of over 97.5%. I guess what impact does this level of efficiency have on both operational costs and I guess use case versus what you'll see with the HYC 400 where power isn't distributed?
Yeah, I mean, so that 90, greater than 97.5% efficiency is something that we're actually carrying over from the move to silicon carbide. So when we moved to silicon carbide back in 23, we landed a little bit above 97.5. And now, as we continue to iterate on that and make it more power dense, we continue to carry over that efficiency. So where the efficiency really comes into play, right, is the more and more and more megawatts of electrons that you're pushing through, then that 2.5% efficiency, loss, let's say, becomes more and more significant. So it's a numbers game, right? So the more volume of electrons that are flowing, that you're selling, and the less loss that you have means basically more money to the bottom line. Frankly, up until now, efficiency has not been such a big story, right, on the market due to lower utilization. But as utilization increases, as we start talking about megawatt charging, then the efficiency is going to come much more into play, and it's purely a play on the bottom line, because if you have less loss, you have more profit, right? So the higher the efficiency, the less the loss, and the more in your pocket. So I think over time, as power usage and consumption continues to increase, this one will become more and more critical.
Okay. And I guess are any of these HYC 1000s in application today? I know Alpitronic has way more of set infrastructure in Europe versus here in the United States, but you guys are slowly building up more over here.
Yeah, so we are testing. Okay, we're engineers, so as engineers we test. So we are really right now in the test mode. So we don't have any necessarily production, customer facing, public available, but we are in the test phase right now. Yeah. So right now, the plan is this. First of all, we're starting from Europe. To your point, that's our legacy business. So we're starting in Europe first, and we'll really be starting production in Q3, let's say, of this year of 2025, and then we'll start production for the U.S. in Q1 of 2026. So let's say roughly 1 year from now, we'll start initially producing in Europe. And then over time, of course, we always like to have a balanced footprint on production with a bit of redundancy. So the supply chain industrialization will evolve over time, but we're definitely going to start in Europe. One thing that I didn't mention just now that we're on the HYC1000, we're launching the distributed architecture, but also the MCS connector. But what this means is that for any site, you can have a mix, right? If you're in Europe of a CCS2 connector and an MCS connector, you can have a mix. You can have only MCS or MCS and CCS. And the same holds true in the US. So in the US, you can have CCS1, you can have an ACS, or you can have MCS or a mix of the three. There's 8 dispensers, or let's say connectors, allowed per HYC 1000, but the mix on how you want to do that is purely up to our customers. So it really gives you that flexibility. You don't have to rip and replace. Gives you a bit of future proofing. As we transition from CCS to NACS, or as the MCS standard becomes more and more available, you're able to swap out cables, or perhaps the dispenser going from CCS to MCS. Trucks today are typically on CCS, right? Over time, they'll go to MCS. So it's really a no regret investment that allows you to future proof a bit and have only a minor, investment to upgrade or change cables over time. So this, I think, also with this flexibility, modularity, future proof, is really one of the other value propositions of the new product line.
Right. That's something we're seeing a lot more with charge point operators setting up, and just infrastructure as a whole, future proofing it, because as we're seeing higher voltage EVs, as well as our EVs that are like semi trucks, which are taking in, right, a 1 megawatt of energy, you want to make sure that infrastructure supports both of those. And so, right, 8 silicon carbide carbon semiconductors, and that give you those 8 dispensers, which 125 kilowatts each.
Yeah, exactly. We're calling it the 6 stack Gen 2. So 8 stacks, 8 times 125 gets you your 1 megawatt. Now you don't have to start with 8 stacks. You can start with example 4 stacks, and then have the flexibility in the future as your power needs grow to add 4 more stacks, for example. Also in the future, we'll have the ability to connect a second power unit. So that means up to 2 megawatts. That's going to be a little bit later in the future, but yeah. So again, coming back to the point on future proof, we know over time power needs are going to increase, and so having this modular, flexible, future proof architecture is really one of the requests from our customers.
Awesome. Where do you think charging infrastructure goes from here? Right, we have HYC 400, we have HYC 1000. What do you think is next? Not only, I guess, from Alpitronic's perspective, but for future proofing infrastructure.
I think it's always going to be a mix. I mean, I think there'll be a bit of cannibalism from the HYC 1000 across the 400, but I don't think it's an or. I think it's an and that really is just going to depend on use case, power availability, future potential power needs. Um, you know, I think that there's space right now for both use cases. It's not going to be one or the other. As you get to more ports, it becomes much more cost efficient to switch over to the HYC 1000. If you have a smaller charge park, then probably it makes more sense to do something standalone. So again, always really depends on our customers and their use cases. I don't see one architecture winning over the other one. Really dependent on the use case.
Okay, so yeah, it's not like a total next generation where it's cannibalizing, as you mentioned, the HYC 400. They can work and coexist in different applications. Is there anything you guys learned from the HYC 400 that you guys directly implemented into the HYC 1000
Well,
dispensers?
yeah, that's a great question. I think I would say that all of the learnings, right, of the journey in the HYC 400 have gone into the HYC 1000. And I think a lot of the feedback we get from our customers is they really appreciate our reliability, the uptime, the serviceability that we have of our products. So I think we've carried over all of this. In fact, this you know next generation 6 stack or Gen 2 is going to be the only power module and 6 stack that we're making across all product lines. So it's something that's going to be continuing on that legacy of quality that we have. All of those learnings are going to continue. All of the data that we've collected that we're able to find patterns and improve our product is just going to carry on and carry into the HYC 1000. So it's just really an extension of what we've done today. Now, of course, some things are a little bit different. Dispensers are smaller. Customers are requesting a lot that the screen maybe is on the front. Sometimes they want a touch screen, a bit more ambient light. So we've incorporated all of these customer requests as well into this new product launch. But I think the main point is that we just continue. It's not a new architecture from a power module point of view or power conversion point of view. So we're going to continue to bring over that same quality that's appreciated by our customers into the new units as well.
I think this kind of settles all the questions I have about the HYC1000. Are there any, I guess, statements for our viewers who may be more curious about the HYC1000 that they can learn, or where can they expect to start seeing these?
Yeah, well, I think I mentioned that maybe earlier that we're starting with the launch first in Europe. That's the priority right now. So that's already quite moving. And now that we've made the official launch, the documentation is already, of course, well underway. So we'll be putting updates on our website, so you can check us out there for updates in the future over time as we go. But again, we'll start production next year. So we're a little bit in advance. We're probably not too far in advance for getting that updated, but that'll be coming more and more over time. You can also come and see us at ACT. We'll be there at the end of April in California. So you're also welcome to come by and ask your questions.
Hopefully we get someone from Out of Spec out there. We can kind of see more of the hardware in person. But this is exciting, especially where seeing Alpitronic expand into, instead of all of the power being distributed directly into the dispenser in one, it's now a cabinet that's separate from your dispenser. And that, I guess, would allow for some more modularity in situations where, I guess, larger dispensers wouldn't exactly work. But the more charging infrastructure, the better. Thank you so much, Mike, for joining me. If you guys have any questions for Alpitronic or Mike in the comments, feel free to leave them down below, and I'll try my best to reach back out to you, Mike, and try to have those answered.
Sounds good. Thanks, Isaiah. Good to see you.
Nice to see you as well. Well, thank you guys so much for watching. My name is Isaiah. This is the Out of Spec podcast, and I will see you guys in the next one.